Hello, I'm Jill from New Forest Water Watch, and I'm going to show you how to take a sample of water to test for nitrate and phosphate safely. So we've got a variety of equipment that we can go through, and I'm going to introduce you first of all to the jam jar, which is what we sampled with throughout last year in Lymington. A jam jar on a piece of string is absolutely fine for sampling. Put it in the water and pull up your sample. But I've got a better piece of apparatus that I hope we're going to be able to supply you with, and that's an extendable sampler which magically extends to a metre long and allows you to sample very safely. Notice that I'm on very firm ground. Do check your ground, that it's stable. Do check that you've got sensible footwear, no flip-flops, certainly no bare feet, and above all, check that you've got disposable gloves. So I'm going to take a sample. I've got to lean over a bit, and that's one reason why I'm using the extendable sampler. So I'm going to take a sample, I'm going to wash it out, do that a couple of times, and then bring up my final water sample. So we'll now move on to the testing phase. We're now at a firm surface where we can manipulate the test reagents, and I'd like you to notice what we've got on the table. We've got our sample here, we've got a little measuring cup, we've got two plastic reagent tubes, we've got a colour card which will become very evident at the end, and our disposable gloves. So what I'm going to do now is show you how to use these reagent tubes to do the actual test. So here's our cup of water that we obtained from the river just now. So I'm going to dip that in, and I'm going to take a 1 ml sample, and I'm going to give it to Chris here. It's very, very useful, who notice is in gloves too. It's very useful to have a partner for this stage. So I'm now going to take one of these two reagent tubes. I've picked up the nitrate tube. Right at the bottom it says NO3 for nitrates. You'll notice the other end is a little plastic pin which has to come out, and I'm going to pull that out now. Don't chuck it in the river, keep that and recycle it. What we do now is squeeze all the air out as much as we can, and we do that by folding the tube over. Think getting the last bit of washing up liquid out of your washing up liquid dispenser.
Or toothpaste.
Or toothpaste. So we're going to squeeze the air out, and we're going to invert it over our little tube like that. And we leave go, and we suck all that water up. Now, if you notice, there's a 1 ml mark on there that I filled it up to, and that means that we've now got 1 milliliter of water in the reagent tube. Thank you, Chris. So this is an important bit. You now shake very vigorously until it's dissolved, and when it's dissolved we will start a stop clock. Thank you, Chris. We will start a stop clock, and we will time this for 3 minutes. So it's not yet dissolved. Don't shortcut this stage because it's important. You will get an underestimate if it's not timed correctly. So,
An iPhone or something similar, very useful.
yeah,
Okay, cool.
but very difficult to do this on your own. So a lot of vigorous shaking. I think I've been doing this for about 45 seconds, and still not dissolved. The temperature is low, So we'll go on for a little bit further. Shake, shake, shake. Okay, I think that's now air bubbles in there. Okay. And we now start the stop clock and we leave this for 3 minutes to develop, hasn't it?
We're at the end of, nearly at the end of 3 minutes, and that's when we will take the visual check against the card of what's in the tube. Time.
Okay, so here's our reagent tube. And what you do, make sure that you've got the right one. N for nitrates, P for phosphates. It's very simple, but it works. So we're going to run up here, and what we're looking for is not an exact colour match, but something in between the two. Now I would say we need to go up further than that, and I would say that that is somewhere between 0.5 and 1. I think if we go any further it's too pale. So we're between 0.5 and 1. So that is our reading, and you will now record that either on a recording chart or in a notebook. So, second test, we're going to test for phosphates. So here's our phosphate reagent tube. Check again that it says phosphate at the end, PO4. And we're going to do exactly the same thing as we did for nitrates. We're going to squeeze all the air out, like that. Fold it over my finger to stop it going back in. I've already taken 1 milliliter in this little measuring cup. I'm going to give it to Chris. And we're going to invert, turn it upside down over that tube. And we're going to suck up the entire contents of that little device, that tube. So in there we've got 1 milliliter of water. So it's all gone. As before, to shake quite vigorously to make sure that all the reagent is dissolved.
5 seconds to run. Coming up to 5 minutes, which is when we'll stop now.
Okay, so here's our phosphate tube, and you can see that this is really good news for Avon water behind me. There is virtually no colour in the tube, and we think that any coloration, the slight yellow colour, is due to peat in the forest stream from which it originated. And to illustrate that, here's our original cup of water. You can see that it's not completely colourless. So very good news on the phosphates in Avon water. It is below 0.02, and that's what we'll record. Now I've demonstrated one way in which we can test for nitrates and phosphates. There are other ways, and some of you may well prefer to do this, and we will make these available as well. These are just test strips, and you can see that they test for nitrate and nitrite, and it's a very, very simple test, very like you would use for a fish tank. So you simply dip your stick in and let the colour develop. So we've now let that run for 30 seconds, and we do exactly the same thing. We run it up the tube, and in fact we've got a slightly higher reading with the nitrate than we had with the other test. That might be because we're slightly over the 30 seconds. We can also test for nitrites. You can see that that's lower. We're not aiming to do that.